Hello everyone. So thank you for the invitation. Today I'll introduce you to an extraordinary company with a strong mission towards the protection of our ecosystems. Alef Farms grows delicious beef steaks from stem cells without killing animals nor harming the environment. Our mission is to build resilient and sustainable food systems for tomorrow. So why are we here today? The thing is that, as we all know, the food supply chain, as of today, has become critical infrastructure to feed us all. The main problem is that it comes with a lot of issues. The first one is that intensive farming triggers pollution, massive deforestation, loss of biodiversity and degradation of soil and waters. Second thing that you might less know is that bovine livestock alone consumes half of our arable land. In addition, feedlots and slaughterhouses can fuel the emergence of pathogens such as COVID today and other foodborne contamination. A consequence is that over 70% of all the antibiotics produced on Earth today are used for factory farming, and they trigger or contribute to the buildup of antibiotic resistance, which kills a lot of people on Earth. So, as you can understand, we have a problem and we need a solution. A solution that provides fresh and nutritious food without pumping all the natural resources that we have on the planet. This is where Alef Farms comes into play. So our technology stems from medical research from Professor Shulamit Levenberg, whom you'll see on the left side, from the Cayhon in Israel, and her work is at the convergence between stem cells, tissue engineering, and 3D bioprinting. And this exceptional IP that she developed in 3D tissue engineering has been transferred to the food technology, to the food systems, in order to focus on meat production. So we are bringing together biotech and food tech in order to feed the world efficiently. You will ask me, how does it work? So this is a very simplistic design. We mimic nature. Actually, we cultivate high-quality meat cuts directly from the stem cells. So instead of growing meat from an animal, which takes 2 to 3 years and a massive amount of natural resources, and half of the beast is getting thrown away or discarded or wasted, we are just taking the cells and we are just providing them with the right nutrition. So we can grow specific cells like muscle, fat, connective tissues, and many other different types of cells from stem cells. And we feed them with the natural growth medium within a bioreactor. I can go into details if you want later. So instead of 3 years, it takes us less than 3 weeks, to grow the exact same steak, and while using a tiny fraction of the usual resources needed. So the result is a full 3D structure state, and we make sure to design and test it with leading Michelin star chefs and meat experts in the world in order to make it an absolute best experience. And I can tell you, as a French person, it's delicious. So why space? So you have part of the answer on the right side. Sorry. Yeah, why space? So spacefaring is limited by 2 things. The first thing is food storage, and the second thing is the decay of our food quality in time. So we cannot live and thrive on the moon or Mars on prepackaged food. This is impossible. And up there, in order to reach peak capacity, peak physical and cognitive performance, you need a very strong motivation. And one of the best motivation we ever had is food, good food. So good food for us is really critical, in a sense that it may be even vital in certain occasions when you're far away from home and in a very, let's say, hostile environment. So as you understand, Alef Farms could be transformational for spacefaring, in the sense that our partner space agencies understood from the beginning that we're already at the lab scale, and at the lab scale we can produce already enough food for a small crew. And the most important from the bioreactor I showed you is that the most important is that 90% of our inputs is water and a little bit of sugars. So potentially, we don't need much. We have water on the moon, we have water on Mars, and we could save a massive amount of money in terms of Earth mass transportation. You can see the prices here to send food on the ISS or on the moon. It's massively expensive. So in addition, our meat is sterile, which is absolutely essential for space. So we don't need any gamma ray to send it to space. Second thing is that we have a much longer shelf life, which means that it's less waste. Okay. Above all, it can be tailored and adapted for personalized nutrition. I'll go fast. So besides this, we see frugal systems designed for space as a model or sustainable solution for the future on Earth. And it forces us to think of optimal systems also to benefit Earth. I'll go to our milestone. So you can see the milestone that we completed on Earth for the moment. So we were the first to cultivate a 3D steak. We're the first also to cultivate a 3D bioprint meat on the ISS 2 years ago. And last year we bioprinted a ribeye steak in 3D with 3D bioprinting. Our milestone for space to finish, so the first one we already discussed about, so this is biofabrication of meat. The second one, in 2 weeks from now, we are all going to Cape Canaveral for Axiom 1 mission. And the one on the left is our Israeli astronaut Eitan Shtiber, who will demonstrate our capacity again in space. And we will have the exact same twin space lab on Earth to demonstrate the capacity. My point in the end is that we are developing several programs. One, the key one is the NASA Deep Space Food Challenge. And for that, the purpose is to develop, it's absolutely challenging. We have to develop food for a crew of 4 people for 3 years without resupply, which is absolutely insane and challenging, as you can imagine. And nobody has ever succeeded to date, and this is precisely where we are going today. And obviously, this is how we want to build resilient systems for the world. So thank you, and always open to any ideas and cooperations.
Thank you to Alef Farms. Can I ask Aurora now, please?
Yes, I believe it's better. Just 1 second. We will show a video first. So we are Aurora, and we provide deorbiting and propulsion solutions. And I don't know if you have ever tried to use a Swiss knife as a propulsion system. So this is exactly a propulsion system, and this is what we do. We are very good at micro technologies and light technologies to apply propulsion systems in microsatellites, nanosatellites, which don't have it today, right? So our booth is just behind this forum there on D22. Feel free to come and check it out. So we use the propulsion systems for anti-collision and small moving you on space. The propulsion systems are water-powered, so we have sustainable solutions. And I wanted to show you a video, which is much easier to explain why should you need this type of light, almost non-existent propulsion systems automated on space. Yes, yes. With sound. It's not that video, right? So it's always good to have some real steel devices. So anyway, we have just 5 minutes. So basically, as I said before, what are we good at? We are very good at micromechanics. We have propulsion systems water-powered, and we know what it takes to produce theater. So our upcoming solutions are going to be plasma brake based. And what we wanted to show today, it's the smallest propulsion system of this size, like 0.05 U. And it seems our slides are also very small. Yeah. Oh, wow. So that's it. So it's really the smaller part of what I was showing here. You can see a euro coin. So why do we need this? This is used for constellations and CubeSats, especially many of the constellations are doubling the size of satellites, and they are including propulsion systems, very light base. And this is a launch. This is a real product. You can order it. There is pricing for it. We manufacture it ourselves, so we have a manufacturing plant in Helsinki, small, and are very happy to introduce this today here. I assume, okay. As I said before, this is what we allow our industry to move on space, either with collision avoidance systems or with plasma brake solutions for the orbiting. On the plasma brake, we have a couple of LOIs where we are starting the development, and the collision avoidance is what we are selling right now. So what are we looking for? We are looking for business, of course, and we are looking for research institutions who are interested on finding opportunities with us, with these products. So far, that's all. Thank you.
Finish all of them, I'll put the video back up so you don't lose that video.
Okay.
Okay?
That would be nice. Or even if you could do it after.
Yeah. Or if you, or ask Timo just to resend it. Yeah.
Now.
Exactly. Just tell Timo to resend it to Diara. Get her email address. Resend it, the video, and we'll do it. Okay. Thank you very much, Aurora. Celestial. I think it's Johannes. Oh, there he is. Which one? This one or that one?
Thank you.
You'll see me waving in the background. Johannes, lift the microphone that way so it's facing upwards.
Okay, okay. Okay, good day everybody. My name is Johannes Schumacher. I'm one of the founders of Celestial. And Celestial is a small satellite systems developer and provider. And okay, this is the next slide. Perfect. So we supply small satellites with systems. Our focus is on communication technology. And of course, there's many challenges with small satellites. They have limited power and volume and lifetime. And of course, there's a big problem with no longer operational satellites because they cause a huge damage or lost assets. And up to 30% of these problems are caused by the communication systems. So these systems, antennas and communication systems need to be made more reliable. And that's what we focus on. We want to make them reconfigurable and high performance and low weight, low cost at the same time. And for this, we are working on antennas and transceivers. So we have two antennas which are ready, which are finished in development, which are on the market right now, which is a S-band patch antenna and an X-band patch antenna. The S-band antenna I'm holding in my hand right now. This is actually the space-grade model, which is also going on an IOD mission in the summer of this year, and then it will reach TRL 9. And we also have a smaller X-band patch antenna, which is roughly 3 by 3 centimeters. So for both of these antennas, we compared our system basically with other systems on the market. And you can see in these two diagrams, the blue circle is our system. And we compare this in terms of performance, the y-axis, and mass, the x-axis, and of course the commercial price. And for the patch antenna, we are very confident that our system is basically up to 3 times better than the baseline set by most of the other systems. So as I mentioned, we develop and supply satellite subsystems, and for this we are fairly high upstream focused in the value chain. And the way we deliver our products, basically in the entire development cycle, we focus on development and engineering. All the manufacturing and testing is outsourced for us to partners and suppliers. In the end, we may help the client also with integration. But basically, we are a development company, not a manufacturing company. Yet still, we think our business is scalable because there's just so many satellites coming up, and we can basically supply multiple antennas to satellites, which also usually need redundant antennas. But most importantly, what I want to talk about is our upcoming R&D, which is a solar panel integrated small satellite antenna. And there's a few steps that we want to take. First of all, we want to make patch antennas transparent. And for this, I have one actual antenna in my hand. So we're going to use a transparent substrate material. And then besides the material, we also want to innovate on the processes being used, which means we want to use electronics printing processes to print the actual antenna on the substrate, which is what I'm holding in my hand right now. This is a printed antenna. And in the next step, what we want to do is we want to integrate solar cells into this transparent antenna. I'm holding here a demonstration model, and you can see this has already integrated solar cells. So in the end, this system will be able to basically generate power and at the same time communicate. And with that, we are combining two payloads, which are usually separate, into a single payload and save a lot of space on the satellite. And also this system is even much lighter than the conventional antennas. So that's what we're working on right now, on new materials, new processes, and integrating separate payloads, and basically developing highly integrated satellite antennas. And the bigger vision for the system is also to make this available for deep space missions and enable deep space missions. Eventually, we see a big market coming up in the moon, of course, but also later stage around the Mars. Of course, there's also a big market for satellite antennas. There's also potentially a drone market for a technology which is also relevant to take antennas, but we're focusing on the satellite industry right now. And we based on our calculations, there's a 600 million euro addressable market in space segment antennas alone. Just briefly about the company, we are based in Germany and we have a subsidiary in Luxembourg. We are an ESA BIC alumni, and we have been in the industry taking part in Inner Space Masters, IGLUNA, ESA BIC, and also Fit for Start. and also work with ETH Zurich for to be part of their educational program. And then finally, what we're looking for right now is investment of roughly 200,000 euros for the upcoming time to fund our R&D. That's basically it. Thank you for your attention. We have the booth at BO8. If there's any interest, just drop by and we can talk. Thank you.
Okay. And our next company is Ezeco. Laquelle? Comme ça ou c'est là?
Non, c'est bien. Et j'ai pas le. Ok, je sais pas. 1, 2, 1, 2. Ok. Okay. Hi, everyone. Thanks for being here. So we're going to talk about data. So we are Ezeco, and our product's name is Appalgo. And we are here to make sensor data usable again. So data is everywhere. This is not a secret for anyone. This is the new gold. And it's also the case in space. We know today that a satellite can generate a lot of data. And some of these data are sensor data or time series data that you can see here. Basically data that evolves in time. Of course, one of the problems we have as data scientists and as people that analyze data is that we spend 90% of our time navigating, understanding, labeling, and annotating data. That takes a lot of time, but it's a crucial element of data science and understanding how data evolves. So today, as an expert, if I show you this data from 3 sensors and ask you what is happening here, you'd probably tell me, I have no idea. So what we're trying to achieve is make this data usable. Here you go. Usable with a search bar where I can literally search my events and to arrive to this. Now, if I ask you what's happening, probably you have more ideas what's happening. Now you have the annotations, you have the labels, and you have the events that happened in your assets with the labeling. How do we do this? So it's easy. We have 3 steps. After having integrated data, we have an AI algorithm that will generate candidates for labeling. These candidates will appear with a gray bar. The expert will come in and with an easy interface label 4 or 5 events. After that, we have a label propagation algorithm that will take those events, go through all your data, and label the data with the events that matches the annotations of the expert. And that's how we label the totality of the data. So Appalgo is, what is Appalgo? So the product we have developed actually is what we call an augmented analytics for sensor data or for time series data. We're trying to unlock machine learning, labeling, and search capabilities for these data. Today we are in aerospace. We're also in the automotive sector. We're also in the defense sector. And what we do today, the insights we are delivering to our clients are really critical to their missions. From labeling to anomaly detection to pattern recognition functionalities. That's it. Thank you so much for having me. If you need to contact me, here are my details, and we're there in the safe cluster. Thank you.
Okay, and our next company is Cayhon Space.
That's a clicker.
Good afternoon, everyone. My name is Aras Faizi. I am the co-founder and chief technology officer at Cayhon Space. I'll wait for the, oh, there we go. Here it is. Thank you for your time. Today, there are, too fast. There are more than 1 million pieces of debris larger than 1 centimeter in diameter orbiting the Earth. They are traveling at orbital speeds, which is 10 times the speed of a bullet, say, give or take 30,000 kilometers an hour. At these speeds, a small piece of debris, size of a penny, if it strikes a satellite, it will destroy it into pieces. Not only it will end that mission, but the debris from that collision will continue to threaten other satellites. On a bad day, a chain reaction known as Kessler syndrome can render an entire orbital regime unusable for generations to come. So if you look at it, our modern way of life is dependent on space, from navigation to agriculture to defense, you name it. Every aspect of our modern life is dependent on space. So anything that happens in the space is not just staying in space, it's affecting our life here on Earth. And Earth is an infrastructure. I mean, Earth orbit is an infrastructure, and that is how we need to treat it. A recent study at University of Texas, Austin, concluded that 95% of lower Earth orbit's carrying capacity is taken up by space junk, and that was before the Russian ASAT test, so you go figure. By the way, the animation is not working. It was a lot more meaningful than this, but since 1960s, we've launched about 11,000 satellites. Just in the next decade or so, we're planning on launching 10 times that, 100,000 satellites in 1 decade. Not only that, we have better technologies to detect and track orbital debris. So far, we've been tracking about 30,000 or so. With the introduction of the new sensing technologies, we're going to track a lot more than that. So all of that combined, what that means is the way that satellite operators today are dealing with upcoming collisions, or called conjunctions, is not going to work. The process is breaking down. It is prone to human error, it's prone to delays, and it's simply not scalable. And it's not science fiction, it's happening on a daily basis. Every satellite operator is dealing with it today, one way or another. One of our customers is seeing 1,000 daily notifications for their constellations, 1,000. Now, and the conjunctions are changing, the nature of them are changing. How? First of all, they're more frequent. We can see daily increase in number of conjunctions. And we're seeing a lot of last-minute conjunctions, which results from low thrust propulsion and the long list of other phenomena. But more importantly, we are seeing a lot more operational and unoperational satellites. Imagine 2 satellites coming into conjunction in 12 minutes, in 12 hours. They have no way of communicating with each other. They both do something independently, and instead of reducing the risk of collision, the risk of collision increases. That's why we've developed Pathfinder. Pathfinder is the first and only coordinated and autonomous satellite collision avoidance system. It coordinates autonomous collision avoidance maneuvers from a machine-to-machine level, and it reduces the response time to potential collisions by 95%. We do that. We've built a solution that it is plug and play. It is interoperable. It can work with any kind of data sources. And in every single case, we can demonstrate that it is better, faster, and cheaper than in-house development. Now, just taking 5 years back, 5 years back, you had to be Airbus or Northrop Grumman to be able to fund, develop, and launch a space mission from design to end of life. Today, every step of the way, you can find a turnkey solution that provides you with design and launch technologies. However, we realized one thing was missing, and that was spaceflight safety. So we're introducing the spaceflight safety as a service or as a software, as a category. As a part of that, so far we have sent 50,000 conjunction notifications. We are providing our service to 400 satellites from 8 commercial customers, Europe and US. And we have $45 million worth of deals, top of the funnel. We have recently raised $4.4 million in capital, in private capital funding, that is funding our development. And as you heard earlier, we just announced PROACT. It's a technology that we developed in partnership with our European partner, Aurora Propulsion. And it is the first and only integrated collision avoidance solution where we detect a solution, we calculate a maneuver, it is directly commanding the propulsion system that creates the avoidance maneuver, making the spaceflight safer. So our mission is to make spaceflight safer. We are here to improve and increase our partnership, especially with European partners, because space is for everyone. Thank you very much for your time.
And our next company is Klebsidra. There we go.
Okay, good afternoon, everyone. My name is Angelo Guillino, Business Development Manager at Klebsidra. And what we offer from Klebsidra is time. Let me explain this in more detail, and I hope you can understand this after this presentation. When we created Klebsidra, we identified that all edge computing sectors, or embedded systems, whatever you want to call them, share a common challenge, which is data processing limitation for real-time applications. Currently, there are two approaches to face the problem. We can upgrade the hardware, but this is costly and it is not always available for the user, for example, for space applications. We can use cloud solution, but it has other limitations like long latency and, of course, cybersecurity issues. So none of them solve exactly the problem. So what does Klebsidra offer? Klebsidra offers a third approach using software. By the use of very advanced and powerful techniques, we have been capable of developing software solutions which increase data processing in real time with zero data loss and a reduction in the power consumption of the processor. So when we say that we offer time, I mean exactly this. We can offer to the user to increase the performance with minimal integration effort immediately and on the same hardware. We have two products. Our core product is our SDK. We can use it for general data processing. We are agnostic to the type of data. So we can process data from any kind of sensor, LiDARs, cameras, and so on. We can use our SDK to increase the performance of heavy algorithms like encryption, data compression, virtual reality. And we have a second product, which is what is called in the AI world an inference engine. So what we can do is we can take any kind of machine learning algorithms and run it more efficiently on edge devices, as you will see later. This is a benchmark that we have for our SDK. The idea here is to show you that we can process 4 times more data with a reduction up to 50% on the power consumption, just by the use of software, with no extra hardware or cloud computing. Some use cases related to image processing for your space applications, data recording, and we are working on encryption algorithms for satellites. This is a demo that we have available for our Klebsidra AI solution. I think you don't see it properly, but the idea here is to show that we can process double amount of data with half of the CPU consumption compared with main market leaders, which are TensorFlow and OpenCV. So, as I said, we provide the inference engine solution, but we can also provide with different algorithms in different fields, like computer vision, vision navigation, and also object detection. Sorry. Finally, this is an integration example. We can combine our two products for different applications. For example, for Earth observation, what we can do is we can process images coming from a camera on a satellite with our SDK more efficiently, send these images to an algorithm that can be Earth object detection, and run it with our Klebsidra AI inference engine. So in a nutshell, what we can do is we can increase the performance of real-time applications with minimal effort of integration and on the same hardware. That's all. Just to highlight that last December, we have closed our seed investment round of around 1 million Swiss francs. We have started some projects and pipelines with big players in the sector. And now, currently, we are more focused on commercial actions like lead generation, partnership, proof of concept and so on. So on behalf of our team and myself, thank you very much for this opportunity.
Okay, and pale blue.
Hi everyone. My name is Hiro, coming from Japan, and the CTO of Klebblue. So my firm, Klebblue, specializes in developing next generation propulsion system in space. So I founded Klebblue, my firm, in 2020 with 3 co-founders. And also, for the last 10 years, we have been working together with JAXA and the University of Tokyo to build and launch our new technology. So, before I'm going into the detail of Klebblue, let me talk about a quick primer about spacecraft engine today. So, basically, spacecraft engine can be used for nearly everything. So, if you want to go into the orbit or the moon, you may use a spacecraft engine. And also, after you get into orbit, you may need spacecraft engine to keep your orbit against gravitational perturbation or air drag. And additionally, with more spacecraft and more space debris accumulating in orbit every year, we may use propulsion system to avoid a collision. But there's a problem. The problem with space engine today is that they basically use a fuel that is either considerably dangerous, very rare on Earth, or very expensive. And that makes it very difficult to scale commercial space activity. So our mission, our goal is to solve this problem by powering spacecraft with our new technology, the ultimate green propellant, water. So the reason that we focused on water is because when you look at wide variety of propellant used today and assess it with viewpoint of how safe, how abundant, and how affordable, water was the only one that met all the criteria. So far, usage of water has been tried before, but in many cases, they use water as just steam. So they heat up water and make steam and exhaust those steam. But in this method, there is a problem. That is, the steam itself has very bad fuel economy. So what we discovered here is, if you take a part of the steam and provide microwave and magnetic field, you can convert steam to plasma. And that plasma exhausts positive ion to outside at very high speed. So this means our technology realizes ion thruster by using water. And this ion thruster is patented, and it gives us considerable edge against other water-based propulsion systems. Actually, when you compare our propulsion system with other water engines, you can see that our fuel economy, almost 1,000 seconds, has considerable edge against others. So actually, this fuel economy is comparable with other conventional satellite engines. So this slide shows our current product, CubeSat compatible hybrid engine with ion thruster and water steam jet thruster. And actually, currently we have 3 ongoing projects that fly our product this year. So this year we will see the result of our propulsion system operation in space. Okay? Yes. So finally, let me talk about maybe the most exciting part of water propellant. That is its future-proof. So because water is so safe and so easy to handle, it pairs considerably well with emerging space services. So, for example, orbital refueling. So orbital refueling is underway already, but it's a little bit tricky to use fuel that is explosive or pressurized. But in the case of liquid water, it's very easy to refuel. And also, recently there are some companies already working on mining resources like water on the moon or comets. And once you can free up water in space that exists in space already, and also once you can refuel water while in orbit, as long as your spacecraft run on water, you can continue your spacecraft operation in space without ever relying on the Earth-based resources ever again. So I believe our new technology, water propellant system, can drive down the cost operating in space. And it makes commercial activity in space more scalable and accessible for everyone on Earth. Thank you very much.
PlasmaBound.
Good afternoon. PlasmaBound. We make assemblies lighter. We're in the lightweighting business, a deep tech company. I'm Xavier Montibert. I'm the co-founder and commercial director of PlasmaBound. Lightweighting has always been a problem for the industry, may it be aerospace and space, increasing payloads. And you can see all the activities of all these industries who have to be lighter to go further with less fuel consumptions. And material change has been the big drive in the industry. Changing materials to sorry, it's not moving. Oh. Huh? Oh. Composites. Here we go. Thank you. Composite is lighter, stiffer, and stronger than any other material today, and it doesn't corrode. There has been a lot of drivers, organizations to reduce CO2, Euro 6, CAFE, and so on. It's just difficult transitions here, I'm sorry. Wow. And the drag in the industry has been that right now composite is expensive, but the main problem is its processability. It is a dirty process, it is a manual process, and it is a very temporal process. And this is getting worse with the introduction of thermoplastics, which are way more difficult to bond to another composite or to a metal. Until now, we have developed a technology called controlled polymer ablation. So this is your standard structure, UD, unidirectional, woven, non-woven, peel ply composite structure. And on top of that, you have a layer of polymer, and with a plasma atmospheric equipment, instead of doing an activation, we are doing an ablation, a vaporization, sublimation of that top layer of polymer, revealing undamaged fibers. So now, when you're putting an adhesive or tape to another composite, you have a highly structural bond between these two components. These are examples of surface energies for different materials, from thermosets to thermoplastics. And you can see that we're achieving high values over the 70 dyne, which is the Graal in terms of surface energy. I'm really sorry. And basically, we're increasing that surface by modifying the polar and dispersive content that you have in a composite. That means that with different settings, we can change that mix of polar and dispersive to make it really high, just like, for example, on a fresh peel ply, on a contaminated peel ply, which basically allows us to drive an adhesive to that wettability envelope of the material, polar and dispersive, mixed with the adhesive, polar and dispersive, so that we can match the two and make it bond much stronger. If your adhesive is in the red zone, it will never work. If it's inside that wettability envelope, it will work perfectly. So we can be now predictable in terms of the mix of your adhesives and your composites. This is an independent test from TPRC in the Netherlands, well known for doing tests on thermoplastics. And this was done with a Solvay tape and a Torre PEC. You can see in green hand sanding solutions, in yellow wipes, in blue normal plasma, and our results on the right-hand side with a slight skimming of the surface or a full reveal of the surface. And notably, you can see the standard deviations between these technologies were way much more controlled than all of these technologies. Another test that was done by the TPRC shows that we are the only one having a cohesive failure in the bond. So this is what you're trying to achieve when you're breaking two composites bonded together. Another interesting test is the DCB test. So you're separating your two materials. For untreated or abrasion, you have what you call the catastrophic crack. The parts split in a catastrophic way. And after CPA, you can see that you need way more energy to split these two parts. And on a schematic point of view, you can see on the top left what is happening. It breaks and goes to one surface, then to another surface, then to another surface, and so on. So it takes way more energy to break these two parts together. So what are we bringing to the space industry that is totally disruptive? We bring a clean, highly repeatable solution at speed. We are bringing a process simplification to allow for a volume increase, which is still a major issue in the industry, moving from 10, 100 parts to 10,000 parts. We avoid rivets, or what we call chicken rivets, and inserts to reduce weak points and increase payloads. We improve lightweight sandwich solutions for solar arrays. You can see on top, we can go inside tubes. This is done by hand today. So with our plasma head, we can go inside tubes or outside the tubes and have a much better process control. We remove, as I said, fingerprints. primers, dirt, paint, overspray. We integrate with 3D printing technology, so you would print your first surface. We would come and ablate that surface and print a second surface to it. And overall, we improve bond strength. So thank you very much. These are some types of activities that we're also involved, apart from space, and some of the various companies that we're talking to. We are a small startup finishing a second seed fund round of 2.4 million this week. So great week for us. Thank you very much.